Okay, ladies and gentlemen, let's talk about factoring trinomials. Now, we've already done some factoring. We've already done something like this. 7 x minus 49 equals 0. And so factoring in this case means we take the 7 out front, leaving x minus 7 equals 0, and divide both sides by 7. X minus 7 equals 0, and add 7 to both sides, so x equals 7. There you go. So we factored out a constant. We've also done the following. We've also done x squared plus 3x equals 0. And we said, well, now in this case, I can take out an x, because there's an x comes out of here and one out of here, leaving x plus 3 equals 0. But now, since I can't divide by x, what I need to do is I set each piece equal to 0. And so you get this. And so x equals 0 is done. X equals negative 3 by subtracting 3 from both sides. And that's good. We've even done factoring using 4 parts, but we're not going to worry too much about that. Now what we're going to do is take a look at when we have x plus 3 times x minus 5 equals 0. All we have to do is break this up into its two pieces. X plus 3 equals 0, and x minus 5 equals 0. And so when we do that, minus 3 plus 5 plus 5, x equals negative 3, and x equals 5. Now what we're going to do is, for factoring trinomials, what we're going to say is, what if I have x squared plus 2x plus 1 equals 0? Well, now this isn't as easy. Unlike this, where the pieces were already broken up, all you had to do was split them and solve. Here, we're going to actually have to figure out, how do we split them? Pardon me. Now, this one I'm going to cheat and show you. X plus 1 equals 0. You say, I don't believe you, Mr. Moore, so let's check it out. X plus 1. FOIL. So I do first times first, check. Outer times outer, check. Inner times inner, check. And last times last, plus 1, check. That makes x squared plus 2x, because they're both x's, plus 1. So does it fit? Yes, it does. So this is the correct breakdown for this problem. All I have to do is set each piece equal to 0. Now, in this case, it's kind of silly because both pieces are the same. So if I solve one, I've actually solved both at the same time. So this is what we're going to do. We're going to be working on this step right here, because we've already done this step, and the breakup step. Those problems we've already done. We already know how to do that. What we need to do is we need to figure out how to get it from here to here. What is in this step that is so important? And that is going to take quite a bit of time, because that is not an easy thing to do. Now, let's start with a fresh problem. X squared plus 3x plus 2. Nothing that terribly challenging. What we need to know here, though, is what number is the leading coefficient? The leading coefficient here is a secret and silent 1. Now, the factors of 1 are 1 and 1. For now, we don't need to worry too much about this. Before long, we're going to get into it, though, and figure out how to do more complicated factoring process than involving 1 and 1. What we want to do is break the 2 up and say 2 and 1. So when I say parenthesis, 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 because we know we need 2 parts, and we know how to break up x squared. It's going to be 1x and 1x. So we break those 2 apart. Now we break this apart. Well, the nice thing about 2 is there's only one way to break it apart, and that is 2 and 1. So here we go, 2 and 1. Now, since everything here is plus, why don't we stick with plus? There we go. So here is our problem. We said x plus 2, x plus 1 equals 0. Now, if we want to, we can keep on solving. There you go. X plus 1 equals 0. X equals -2. X equals -1. Have a nice day. So again, this part becomes easy. It's this part that's the challenge. Let's do another one. I have x squared plus 7x plus 6 equals 0. Now, in this case, again, x and x, 1x, 1x, that's not much you can do there. But, we have a 6. So that means it could be 1 and 6, or it could be 2 and 3. So the question becomes, which pair do you want to use? Do you use 1 and 6 or 2 and 3? Your thoughts? Okay, so in this case, we're going to break it up. Equal 0, x and x. And now, which one's going to make 7? Well, can 2 and 3 ever go together to make a 7? No, but 1 and 6 can. 1 and 6. By the way, I could have done 6 and 1, and it wouldn't make a difference because since it's times, 3 times 2 is the same thing as 2 times 3. Commutative property of multiplication. Now, in this case, 6 and 1 are going to work. You say, Mr. Moore, I don't believe you. All right, well, let's try it. Here we go, here we go. X times x, x squared, plus 6x, plus 1x, plus 6 times 1 is 6. So I get x squared plus 7x plus 6. In this case, did it go back to where it should? Yes. So here's what we're looking for. We're saying, what are the factors, what multiplies together to make x squared, and what multiplies together to make 6? That's what we're looking for here, what multiplies together to make 6, but adds together to make the middle number. So what multiplies to get the last number, but adds to get the middle number? The answer here is 6 and 1. Here's what I want you to do. I got a few practice problems. I want you to give me your best shot. So here's number 1. Let's go with x squared plus 7x plus 12 equals 0. Number 2, x squared plus 17x plus 16. Does that work? Yes. Number 3, x squared plus 17x plus 72. Yeah, that'll work. Okay. There you go. 3 problems. Get after it.